Okay, guys, now we're going to talk about what's called dispersion measures. Okay, what that means is we're going to look at different ways that data are spread out and study a little bit the science of determining how far outside of like an average something is. So, like, we use measures of dispersion in things like body mass index, where there's certain like a normal range, and then a doctor would tell you you're kind of outside the normal. Either you're too thin or you're obese, and there's these ranges where we look at, hey, what's normal and healthy and what's kind of outside the range. Another place we use is blood pressure. There's an average blood pressure, like 110/70, 120/80, where they do is healthy. And then if you're outside, you're deviating too far from that, you're viewed at either a lower risk or a higher risk of something. Okay? And by the way, I'm going to give you guys an Easter egg right now. And that is going to be 590205. 590205. All right. So let's talk about dispersion. So let's first talk about range. Okay, let's first address range. The range of a data set is equal to the highest value minus the lowest value. It's that simple. So if I've got a data set that has these numbers, the highest value is 25 and the lowest value is 2. So the range of this is just 25 minus 2, which is 23. Okay, so that's the range. So now we're going to talk about something called deviations. Okay, so the first thing we're going to look at is something called deviation from the mean. Okay, deviation from the mean. That means exactly what we think it would mean. Okay, so let's take an example and I'll show you what it is. 1, 8, 11, 15, 17. Okay, that's data set, let's say. Okay, we're going to first find the mean. Okay, a symbol which I have not introduced yet for the mean is X bar. This means mean or average. So the mean is going to be the sum of all those, the sum of all the xi's, and divided by the number of them. So in this case, it's going to be 1 plus 8 plus 11 plus 15 plus 17. All over, there are 5 of them. Okay, this equals 10.4 is the mean. So if I want to find, let's find 15's deviation from the mean. So let's do 15's deviation from the mean. Well, that's easy. You just take 15 and subtract it from the mean. Deviation means what's the difference between 15 and the mean. Okay? And that equals 4.6. Simple. So that's the deviation from the mean. So a lot of times if I go to the doctor will say, here's the average blood pressure for a healthy person. It's 120/80, let's say. And your deviation from that is this amount. We could just find that by subtracting the numbers we wanted. There's a variety of ways that we could do it. Okay. So now we're going to talk about something called the standard deviation from the mean. The standard deviation from the mean is kind of determines, what's a standard kind of average distance we can be from the mean and still be within a reasonable distance. It's a very useful statistic. So when you go, when I've had my blood drawn at the doctor, you have, iron levels, you have calcium levels in your blood, you have liver enzymes, and so on and so forth. And each of those, if you look at your blood, if you've ever had a blood test, you look at it, and they give you like a range. Like your iron should be from something to some value. Your calcium should be something to some value. Your liver enzymes should be from some value to another value. And as long as you're in that acceptable range, then you are considered a healthy person. Well, how do they determine those ranges? How do they get that acceptable range is the question I have. Well, the way they do it is they look at human beings. They've been taking a lot of blood of a lot of humans and doing a lot of tests for a long time. And they look at healthy individuals and they kind of figure, using statistics and using standard deviations, they determine, what would constitute a healthy range, a standard deviation from the average. And that's where this is really useful, is it helps us to kind of get a gauge using statistics, because we don't exactly know what iron level is good. The only thing we have is a lot of data on how humans have tested with iron levels, and then we can determine. So this idea of standard deviation is extremely useful in helping us to, with data, make predictions about what could be healthy or not healthy, what could be wise or not wise, and so on and so forth. Okay, what's the definition of the standard deviation and how do we compute it? Well, here's a little chart from the book that shows how we do this. Okay, so I'm going to start with a really simple data set here, just short and easy. 1, 3, 5, and 7. Okay, just simple, the odd numbers, 1 to 7. Okay, let's find the mean of that data first. My mean, x bar. Well, that's 1 plus 3 plus 5 plus 7 all over 2. Okay, that's 12 plus, or that's 4 plus 12, which is 16 over 2, which is going to be, actually, my bad, that's not correct. What am I doing? So that's not 2. There's 4 data items there. I don't know why I put a 2 there. So that's 4 plus 12 is 16 over 4, which is 4. So the mean of this data is 4. Okay. So find the deviation of each data item from the mean. So let's do that. For 1, it'd be 4 minus 1, which is 3. For 3, it'd be 4 minus 3, which is 1. For 5, it'd be 5. Oh wait, I'm doing this, my bad. My bad. Whoops. So start off with 1, 3. Let's do this again. I'm doing it backwards. I'm just getting ahead of myself. All right. So for 1, I would take, it says take the data item minus the mean. So that'd be 1 minus 4, which is negative 3. That's all right. And then 3 minus 4, which is negative 1. 5 minus 4, which is 1. And then 7 minus 4, which is 3. Now it says to square each of these, square each deviation. So that would be negative 3 squared, which is 9. And then it'd be negative 1 squared, which is 1. Then it'd be 1 squared, which is 1, and then it'd be 3 squared, which is 9. Okay? So now I'm going to focus on these 4 things right here. Now it says sum the squared deviation, so now I'm going to add all those up. So that'd be 9 plus 1 plus 1 plus 9. Okay? So now I'm going to do the next step. It says divide that sum, which this sum equals 18 plus 2 is 20. So now it says to divide this sum by n minus 1. So that'd be 20 divided by, well, how many items are there? There are 4 items. So going up here, n equals 4. So this would be 4 minus 1, which is 20 over 3, which is 6.67. Okay. So now step 6, we're going to take the square root of that whole mess. So second square root of my answer is 2.58. So that's my standard deviation from the mean. Okay? So that's one basic example. We're going to do some more here. Okay, let's do another one where we compute the standard deviation from the mean. First we're going to find, I made a little table here that's going to help us, but first we're going to find the mean, okay? So let's do x bar. Well, that's going to be the sum of all these, which on my calculator I'm just going to add them up quickly. 48 plus 52 plus 61 plus 61 plus 58 plus 75 plus 91 plus 95, okay? And divide that by how many there are. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of those. So rounding to 2 decimal places, my mean is 67.63. I'm going to go ahead and go with 2 decimal places. So I'm going to write that right in here. Okay, I'm not going to write that right now. I wrote it down. So now I'm going to enter all my data points here in the x column. 48, 52, 61, 61, 58, 75, 91, and 95. Okay? And then my mean for each one of them is 67.63, 67.63, and so on and so forth. I could copy all those down. Okay? So now I'm going to take my x minus this is my deviation from the mean, this column I'm about to do right now. I take my data point and subtract it from the mean. Okay, so that'd be 48 minus 67.63 is negative 19.63. Notice you can get negatives, but that's okay because when you square them, it's going to make it a positive anyway. So I'm going to fill this table out really quick. Okay, I went ahead and filled all those out. Now I would do I would square each of these, okay, for the next step. Square each of those. I'm going to go ahead and do that. So it'd be 19.63 squared is 385.34, and then 15.63 squared. Notice I'm ignoring the negative because when I square it, the negative will disappear anyway. 244.30. Okay, and this is how I would recommend you do this, by the way, is make a table like this. I'm going to fill the rest of this out here. Okay, I filled all that out now. Now what I've got to do is I've got to add all these up. Okay, so I'm going to take all those, I'm going to add them up. So that'd be 385.34 plus 244.3 plus, I'm not going to write them all, 749.12, and I'm going to divide that by n minus 1. Well, there are 1, 2, 3, 4, 5, 6, 7, 8 of these, so it'd be 8 minus 1. Go back to your steps. You take the sum of all these and you divide it by n minus 1. And then I'm going to take the square root of that at the very end, and that should give me my answer. So I'm going to plug this into my calculator. I'll first add these up, and then I will divide it by 7, which is 8 minus 1, and then I will take the square root. So the standard deviation from the mean is 17.57. Okay, so that should help you to compute the standard deviation. That table should help you. It's really just a little bit on the tedious side, but it's really not terrible if you follow those rules. And that should get you through the next section.